Hello, my name is Christopher Collins, and for this assignment I will be presenting to you NumPy, SciPy, Pandas and Matplotlib. This video is just quite a short video, so I can only cover a certain amount in this space of time, but here we go. So NumPy has a lot of capabilities for creating data arrays, particularly has some very good random number creation functionality. So here it's created a random data array of numbers up to 100. It's 3 high by 5 long, and then you can generate random floats. So I'll give the command generate 5 random floats. Float is a decimal point number, and then this command random choice is very useful. You have an array and then you ask it to take 3 numbers randomly from that array, and it picks 3 numbers. And if you don't want it taking the same numbers out, you can also do a further setting false. This comes in useful if you're doing hypothesis testing. You can use NumPy to generate random populations. You can use NumPy to take random samples from a population. And what this program does is basically it creates random populations, a bit like what you'd need for a hypothesis test, and then from the random populations it creates, the user then decides how big of a sample to take from the population, and then depending on the sample size it either runs a t-test or a z-test. And that's where SciPy is handy, because it's got abbreviated formulas for running z-tests, and the one above it's able to run a t-test. Sorry, there's a t-test below there. So I'll just give you an idea of how that goes. So you run it. NumPy randomly generates these figures, and then as a user we pick a sample size, say 10, and it extracts 10 numbers out of these numbers above, and then NumPy does calculations on the size of the data, and the mean, and takes a standard deviation, and then SciPy looks at the p-value, and based on the p-value the null hypothesis is either rejected or we fail to reject it. So here's another random population. And if we go for a bigger sample size, over 30, then it runs the z-test, and again the p-value is greater than 0.5, so we fail to reject null hypothesis. Yeah, it's just something that I put together because we were learning about hypothesis testing this semester and seeing how much of that could be replicated within the NumPy and SciPy libraries. So NumPy has quite a lot of different mathematical functions within it. Haversine formula. It's a formula that's been around for over 200 years, originally believed to be discovered by this fellow James Andrew, but there are some other claims that it may have been created earlier in 1801. Basically, it's quite a complex formula which is used to kind of calculate the distance between two longitude and latitude coordinates, and it relies on things like radians. And if you go over to the NumPy code, there's code for calculating radians, and if you search further online, someone's actually converted the Haversine formula into a NumPy algorithm. So they've imported the different parts of the library: NumPy radians, NumPy sin, NumPy cos, and rounding and square roots. All of those elements are needed to calculate the distance between two longitude and latitude coordinates. I've got the algorithm here, and the function will call those. So if I do Command F, search for Haversine distance. Here is the function being called, and at the moment this code iterates through earthquake coordinates, which are called through an API online, and I compare those to the location of black sod longitude and latitude coordinates, and the algorithm is then able to return a distance, how far each earthquake is from black sod, and then that all goes into a dictionary, which is then converted to Panda's data frame, and then further filtering is done through Panda commands to find the nearest earthquake. But it all hinges on the NumPy components of the code working correctly. So if I right click and run earthquake, down here you'll see that it pulls all of those off, and it calculates that the nearest earthquake is this one, and that does appear to be the nearest dot there. So and as you hover over each one, it's calculated the distance, and that's all through the power of NumPy. So earlier I demonstrated how NumPy can calculate the Haversine distance formula, but if you Google around, you'll also find that other Python libraries such as sklearn have a solution. Also, there's a special API where you can do a pip install for Haversine, and it's got it in a much more abbreviated way, or you can actually use the Google API itself. So there are many alternatives. NumPy is actually a huge library, and I couldn't say that there are any real competitors to it, but what you will find on the internet is a lot of APIs that have perhaps taken an individual sectional portion and made it simpler. So one of the things that NumPy does, as well as having a huge maths library and creating random arrays and different array types, is a lot of the images are basically numbers in the background which can be converted to NumPy arrays, which makes NumPy a very powerful package for image manipulation. So you can open an image with NumPy and resize it. You can, if you open multiple images, you can concatenate them like you could do any other array concatenation, or you can use NumPy to flip images upside down, which makes NumPy quite a powerful tool for creating image training data sets, because it can cut out sections of images, paste different images, make the images more varied, so you've got more training material. So and some of the things I may have covered is that NumPy can check that the shape of the arrays are all the same, because if you're doing machine learning, you've got to compare like with like in terms of size of arrays, and if the arrays aren't the same shape, they can be resized from, say, 3-dimensional arrays into 1-dimensional arrays. So next I'll be showing you a program that I made for image recognition. So it uses SciPy commands to filter and distort images, and it uses NumPy commands to reshape the arrays, and then it uses the sklearn module to perform k-means cluster analysis. Hi, so I'm going to show you a piece of code which uses 3 of the libraries that we were asked to look into. It uses NumPy, it also uses matplotlib, and it also uses SciPy, and other modules are used a lot in it as well. So if I just scroll through the code, first of all, what this code does is that it imports images, and then as those images are imported, there are different filters which are available in SciPy. You can see this nd.image. That's actually from a SciPy library, from SciPy import nd-image, and SciPy has lots of different filters which kind of distort the original image imported, and by putting different distortions and image manipulations, you can actually create multiple images out of one image, so that's more training data for your machine learning algorithm. So here we've got one image of monkey being imported, and it actually creates over 4 new images through distorting them and rotating them. And as you go through the NumPy documentation, because these images, in fact, if you look behind them, are NumPy data arrays, NumPy can manipulate the data as well. NumPy can turn images upside down. Images can be resized, and not only can you resize the images with NumPy, you can actually reshape the image arrays, because the image arrays can be multi-dimensional, but when you want to run a machine learning algorithm on them, they need to then be made one-dimensional. So all of those processes are run on some training data of monkey images and crocodile images, and then as you go further down the code, there's something called a bunch data type, and this bunch data type takes in all of those one-dimensional NumPy arrays and another NumPy array which labels them. So all the monkeys are labeled 0, all the crocodiles are labeled 1, and we run k-means and k-model tests from sklearn, and we use a bit of pandas which is able to kind of do a crosstab to compare the machine learning original data with the results from the training data. So as promised, I'm going to try and show you how the animal recognition program works. So I'm just going to run it, and I'm just going to explain a little bit about what's happening here. So in the background in PyCharm, it's loaded the different images. So here's the original image, and then different distortions have been applied by SciPy to create more training data of that image. So when you look at what happens when run has been pressed and I've asked it to print what the images are, it's showing NumPy arrays. Now if you notice here that there's double brackets, this means that these are multi-dimensional NumPy arrays. So here are the arrays of the monkeys which have been imported. So there would be like the original one, and then when a distortion is applied to it, then the numbers will change with each distortion. And then finally NumPy command is used to reshape it from multi-dimensional array into a single dimensional one, because that's the way machine learning is able to process it. It all has to be one-dimensional for this kind of test. And the other thing that has to happen to the pictures is NumPy, or whichever visual package you use, has to resize all of the images to the same size, or otherwise the arrays would be different sizes. And here's the same happening with the crocodile data, multi-dimensional arrays, and finally the training data goes through here. Now it's called machine learning because not every time is the learning algorithm that's running in the background is going to get it correct. The more data you give it over time, the more accurate it will get. So with these animals, it's got 8 monkey pictures, and 4 of them it's correctly identified as monkeys, and the other 4 it's incorrectly identified as crocodiles. With crocodiles, something's going a bit awry here. When I look at all the ones, they're matching up with 0s. So at the moment, the algorithm thinks that all crocodile pictures are monkey pictures, and then only half the time it's getting it right there. So what this program does is, if you head on over to Google and find a picture of a monkey, I'm going to use a monkey from the original training data. I'm going to copy the image address, put in the URL here, and it recognizes that this is a monkey. So to conclude this presentation, are there alternatives to NumPy, SciPy, Matplotlib and Pandas? In fact, there are many online, and like I said before, NumPy doesn't really have large competitors, but you'll find lots of individual libraries and APIs online which may take on an element of what NumPy does. Also, the same with SciPy, there are other programs coming on board like TensorFlow and Keras, which would do more machine learning and linear regression and different modeling. Would probably be more advanced in SciPy in those particular aspects, and OpenCV, which deals with a lot of image recognition, will perhaps be more powerful than SciPy's image recognition library. But both NumPy and SciPy, because they've been around long and they've got a large community of programmers and developers behind them, they're kind of like your go-to tools. And then Matplotlib, which is the big graphing library. Other alternatives to Matplotlib, including Seaborn, have actually been developed upon the Matplotlib library, so Matplotlib is still a great go-to tool. And then there are other libraries, like I discovered, like Plotly, which has got mapping capability, which I haven't found in Matplotlib. And then Pandas, I use it mainly for filtering and querying CSV and Excel files, so a library you might want to consider is SQLite, where you can perform SQL queries on CSV files and Excel files. Or there's a library called Modin, and that claims to have a more efficient and better memory management than Pandas, but uses exactly the same commands as Pandas. So you just change the code, you do a pip install of Modin, and you import Modin as PD rather than Pandas as PD. So these things are worth checking out. I did find the Modin a bit of a buggy install, to be honest, and I'll probably be keeping with Pandas, but it's worth checking out the alternatives. Thank you for watching.